So the maximum frequency range is a measure of the full spectrum of frequencies that a person can make. On average, adults are able to produce a maximum frequency range of about 2.5 to 3 octaves. And in order to determine this range for myself, I recorded my voice producing the schwa sound from the lowest pitch to the highest pitch that I can produce on a maximum frequency range. So, according to the spectrograph and the voice report, my minimum pitch is 195 hertz. My maximum pitch is 530 hertz. After calculating this, it turns out that I have a frequency range of about 2 2/3 octaves, or 2.68 octaves. So it's somewhere around the average for an adult. The speaking fundamental frequency is a measure of the average rate at which the vocal folds vibrate during a normal conversation. In general, the speaking fundamental frequency levels are consistent across age and sex, and my fundamental frequency has been determined by recording a one-sided dialogue consisting of 2 sentences. Speaking fundamental frequency. I wanted to go to the movies yesterday, but I didn't get a chance. I watched TV instead. The speaking fundamental frequency is determined by looking at the pulses and then going to the voice report, where you find your minimum pitch, which for me is 77 hertz, and then taking a point reading of the maximum pitch for fundamental frequency, which turns out to be 274 hertz. And for me, my pitch range was around 200 hertz, which is within the range of a 9 to 10-year-old girl. Maximum phonation time is a measure of how long a person can produce a vowel using only one breath. Most adults can maintain phonation for about 15 to 25 seconds. And for the purpose of this assignment, I recorded the schwa sound using only one breath to sustain the phonation. Maximum phonation time. According to the spectrogram, my phonation time was 19.09 seconds, so that's within the average of an adult. So the minimum maximum amplitude at various levels of fundamental frequency is a measurement of an individual's ability to vary the amount of subglottal pressure, which produces more or less intense sounds, along with a greater or lesser amplitude depending on how much the vocal folds are constricted. And in order to measure this range of amplitude on myself, I recorded the schwa sound starting with an open vocal fold, which just kind of sounds like a breathy voice, and it's low intensity and very low frequency, and I gradually constricted or made this part tighter to create a more intense or louder sound with a higher frequency. Minimum maximum frequency. For the minimum maximum intensity at various fundamental frequency levels, I selected my range for the spectrogram and went to intensity, get minimum intensity. My reading is 49.24 decibels, and go to the reading for get maximum intensity, which is 70.49 decibels. So this puts me at a difference of 21.3 decibels, which is within the average of the adult, which is between 20 and 30 decibels. Next, the periodicity of vocal fold vibration describes the amount of jitter within an individual's voice. And jitter is a slight frequency variation found in the nearly periodic vibration of our vocal folds. Extreme periodicity results in a voice that is perceived as being hoarse. And the average voice of an adult has a level of jitter of about 0.2% to 1%. To measure the periodicity of my vocal fold vibration, I recorded a shortly sustained E sound. periodicity of vibration and noise generated by turbulent airflow. E. So, to look at the periodicity for my vocal fold vibration, we go to the spectrogram, look at the pulses tab, voice report, go on down to jitter, and here we see the local jitter, and mine turns out to be 0.425%, which is within the range of 0.1% and 1% for the average adults. Finally, the noise generated by turbulent airflow is a ratio measurement which indicates the relationship between harmonics and noise within the voice. And this ratio is measured in terms of harmonics to noise to harmonics, or normalized noise energy. And for the purposes of this experiment, I use the noise to harmonics ratio. To calculate it, I used the sustained E sound from the previous periodicity of vocal fold vibration, and my results are coming up. So, looking at the harmonics to noise ratio, we go to pulses, back to voice report, and at the very bottom of this little report, we have harmonicity of the voiced parts, and I looked at harmonics to noise ratio, which is 23.928%. This is a bit above average for the average female, according to DACON, which is 18.81 for females and 18.42 for males. So just a little bit above average.